I just wanted to check in for math, make sure that everything is going well and that you're understanding everything. You guys are almost done with Module 5, so I just wanted to check in and make sure that everything was working out. So I'm going all the way back to Lesson 1. Which is describe perimeter. So we've done perimeter a couple times in our calendar math. So we know that the perimeter is just the length of the whole outside of a shape. So now we're just taking what we already know and applying it to shapes that maybe are a little bit funky. So we know that we would just add up this side. I'm gonna use a different color. This side plus this side, the inside, this other inside, the right side, and the top. So all of this added together is our perimeter. Okay, so that's pretty much it for Lesson 1. And then for Lesson 2, where you're finding the perimeter, it would give you each of those side lengths. So maybe this is 4 inches, maybe this is 1, this is 2, maybe this is 3, maybe that's, or we'll say this is 2 as well. And that's 3, and maybe this is 5, okay? And so then it says that you take all of these lengths and you add them all up. So we would do 4 plus 1 plus 2 plus 2 again for the other 2 plus 3 and plus 5 for the top, okay? And that would equal our perimeter. So if we add these all up, we know 4 plus 1 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 3, 12, and 12 plus 5, 17. Okay? So the perimeter of this shape would be 17 inches or feet or whatever it might be. So now, or let's see, 17. I just wanted to double check my math. So that was Lesson 2, was just finding the equation. So then Lesson 3, where it said find unknown side lengths, it would be, you know, kind of the same exact thing, but one of the side lengths would be missing. So maybe this one was missing and it had C or F or another variable. Remember, variables represent unknown numbers, so it would take the place of that side length. Okay, so if that was the case, it would have to give us the total perimeter. So it would say, okay, the perimeter of this shape is 17 inches. What is the length of side length C? So then I would do the exact same thing, but instead of writing 3, because I don't know that it's 3, I would write everything else. I would say 4 plus 1 plus 2 plus 2 plus C, because that's our variable, plus 5 equals 17. So then I would add up everything that I know. 4 plus 1 is 5, 5 plus 2 is 7, 7 plus 2 is 9. Can't add C because I don't know what it is. So then I do 9 plus 5 equals 14. Okay, so actually I would say C plus 14 equals 17. So then I'm going to use what I know about fact families, and I'm going to turn this into a subtraction problem so that C is by itself and I know what it is. So instead of saying C plus 14 equals 17, I could say 14 plus C equals 17, but I want a subtraction problem. And so if I'm doing subtraction, I start with my total. So 17 minus 14 equals C. See how I'm using the same numbers? This is my fact family. So 17 minus 14 is 3, which means C equals 3. So that was lesson 3, which is finding unknown side lengths. So today, you guys did a lesson on representing rectangles with the same area and different perimeters. So now remember, perimeter is the measure of the length of the outside of a shape. Area is the space inside. Now we did area when we learned about multiplication. So remember how math builds on itself. What we do at the beginning of the year is going to help us later on. So our multiplication and what we know about area models is going to help us with area. So it says, I'll just do that first example, where you have a rectangular mural with the least possible border on her backyard fence. So the area of the mural will be 16 square feet. So I know my total is going to be 16 square feet. Now remember, if it's square, that's area. So that's the space inside. Basically what that means is that this number is our product. So I'm going to put in parentheses. It's kind of like our background info. That's our product. So now I'm thinking, okay, what 2 factors can I multiply to get 16? There's a whole bunch of them. I could do 1 times 16. That gives me 16. I could do 2 times 8. And I could do 4 times 4. So now all these factors are numbers that I multiply, will all get me 16 square feet. So now I'm going to draw it out. And so I drew it out on my paper, so I want to show you. Hopefully you can kind of see it. Maybe I'll do it against this board. Okay, so this is my 1 by 16 perimeter. 1 is on the side, 16 is on the top, okay? 1 times 16 equals 16. Now, here's my 2 times 8 area model. 2 on the side, 8 going across. Now, here's my 4 times 4. 4 on the side, 4 on the bottom. Now, these are all different rectangles that I could use because they all multiply to equal my 16 square feet. Okay, I hope you guys can see that. So then it says, what is the perimeter of each rectangle? Now, to find the perimeter, I add all the side lengths, remember? So, if my triangle 1 times 16, it would look like, oh, that's terrible. Okay, it would be really, really skinny because it's just 1 row and 16 in each row. Now, with rectangles, I know if this is 1, the other side also has to be 1, and if 16 is on the bottom, 16 has to be on the top. Okay, so then I would add up all of those lengths because that's what perimeter is. So 1 plus 1 plus 16 plus 16. Now that would give me 2 plus 16 plus 16. So I know 16 plus 16 is 32. 32 plus 2 is 34 feet because that's my unit that I'm using. Okay, so we got to keep this one in mind. So the perimeter of this rectangle, oops, wrong one, this one, equals 34 feet. Okay, so now I'm going to do 2 times 8. This rectangle looks a little bit different because I have 2 rows, 8 on the bottom. Okay? So 2 and 8. Now with rectangles again, that must be 2 and that must be 8 because those sides are equal. So then I would do 2 plus 8 plus 2 plus 8. 2 plus 8 is 10, so 10 plus 10 equals 20 feet. Oh, that's so crazy. So the perimeter of this one is 20 feet. And the one before was 34 feet. Okay, so this just proves how, okay, this area, the space inside is the same, but that does not mean that the perimeter is the same, right? Because I have different side lengths, the outsides. So then let's do our last one. 4 times 4. Again, if the side is 4, the other side is 4. If the bottom is 4, the top is 4. So this one is 4 plus 4 plus 4 plus 4. This happens to be a perfect square. 4 plus 4 plus 4 plus 4 equals 16 feet. So the perimeter of this rectangle is 16 feet. So in your math book, it says that Corey wants to have the least possible border. Okay, so that means she wants the length to be, or the perimeter to be as small as possible. She doesn't want to take up as much space. So which one of these takes up the least amount of space? It would be this one, because the perimeter is the smallest. So that's how rectangles can have the same area and different perimeters. It's just all about the side lengths. Tomorrow you guys are gonna do lesson 5. So let's do a quick preview on that, where you're gonna represent rectangles with the same perimeter and different areas. So this is the opposite of what we just did, okay? So let's look at the first part. So in this problem, so they're selling canvases to paint on. Both canvases have a perimeter of 10 feet. So Gina wants the canvas with the greater possible area. So which canvas should she buy? So now we're saying, okay, perimeter equals 10 feet. So if I add up all the side lengths, it would equal 10. So now we can just estimate what's a rectangle that we would add up to have 10 feet. Now with rectangles, we know, it's a square. I'm gonna redraw it. Okay, so we know that these two sides are the same and the top and the bottom are the same. So I'm thinking, okay, I'll do 4 on the bottom, 4 on top, 1 on the side, 1 on the other side. So in this one, the picture's not exactly accurate, but you can imagine. The perimeter equals 10 because 1 plus 4 equals 5. So it'd be 5 plus 5, and that equals 10. But the area would be 4 times 1, which is 4 square feet. Okay, so that's not a lot of space. So let's think of a different one. I should do these different sizes. Probably more like that one. There we go. There we go. Okay, so now I want another example of a rectangle with a perimeter of 10 feet. So I'm thinking maybe I'll do 2 on the side, 3 on the top, 3 on the bottom. Okay, so 2 plus 3 is 5. So 5 plus 5 equals 10. So this does have a perimeter of 10 feet. Now 2 times 3 though, if I'm finding the area, 2 times 3 equals 6 square feet. So this one is bigger than the other canvas, even though both side lengths or both perimeters equal 10 feet. So yeah, pretty fun, right? So you have to do a little bit of guess and check to see if it'll work out. So don't get discouraged, just keep trying, just keep guessing and checking and seeing if it'll work. And yeah, you'll be all set. I'm super stoked for you guys. It's gonna be a lot of fun. Let me know if you need anything because you guys are gonna do the review and the practice test on Monday. You're gonna do both of them in the same day. So over the weekend, if you need any help, let me know. Yeah, I'm here to help you, and good luck, and it'll all be great. Love your guts, and I'll talk to you later.